Good day, guys. Okay, so I have this question from the 2017 and 18 PSPM, the paper for physics, obviously, coded SP025. Okay, so let's look at this question. This question is on capacitors. It is a question on the combinations of parallel and series. So we can see that, okay, the 3 microfarad capacitor is in parallel with 6 microfarads, and then those two are in series with 8 microfarads, and then those three are in parallel with the 4 microfarads. Okay, so what we want is actually to simplify this particular diagram into, let's call this A, right? And then we have a single capacitor, right? So we want to simplify this diagram into this, okay? And this is what we call, in this picture, this is what we call the equivalent, right? Equivalent um, capacitance. So if we just write that down, so if we have equivalent, right? Which is equals to be honest, the combination of capacitor 4 along with 8, 3, and 6. We can expand that, remembering that the, the 4 microfarad capacitor is in parallel with 836. So I can say that C4 plus C836. Then what I do now is I can expand that. I can expand this particular capacitor combination to get C4 plus, see, they're in series, so I know there's going to be inverse of 1 over something. So 1 over C8 plus 1 over C36. All right. Now again, since I still see more than one number under the C, I can expand that again. And what I will get is C4 plus the inverse of 1 over C8 plus 1 over C3 plus C6. And I know this to be true because they are in parallel with each other. Okay, so let me just color that again for you guys. So 8 and 3, 6 is this one, right? It's this one. And then just the red is just the whole thing, all right? So once I have that, what I can do now is calculate them, substitute the values. So that's 4 microfarads plus 1 over 8 microfarads plus 1 over 3 microfarads plus 6 microfarads, and inverse those, right? So that gives me a value of approximately 8.23 microfarad. So this is in essence a way that you can do, which is sort of like reverse engineering the whole thing. Okay, because we are starting with what we want, which is, oh, I want to calculate the equivalent capacitor, and that is the combination of 4, 8, 3, and 6. And I'm going to expand that whenever I see there's more than one number as a subscript of the C. So I have done that here, and I have done that there twice. Okay, so pictorially speaking, what I have done is actually I have simplified it into this. So if I have, I'm just going to use red this time. Okay, if I have that and I call that the CEQ, I have broken that down into two, which is those two are in parallel, right? Those two are in parallel. So this is C836 and then C4. And then I have broken those down as well. I have broken that one as well because they're in series together like that. Again, this is C4, this is C8, this is C36. I've broken that down again further, right, to get this particular diagram where we have all 4 capacitors drawn out to match this one, the one in the question. All right. So I have started with one and ended up with a circuit that matches the question. All right, which is here we go. All right. So that is all. Thank you. See you in the next video. Alright.